So previously we had been talking about development in general, something that happens to every single developing embryo, male or female. But when we look at development of the sex organs, this is going to be very particular depending on the chromosomes present. If someone is XX, typically they will develop female, and if someone is XY, they will become male. This is because of a very particular gene called the SRY gene, or the sex determining region on the Y chromosome gene. And if that one is present at week 6, the embryo develops into a male. Now, there are other hormones involved in development of sex organs, but the SRY gene is the one we're going to dive into and look at in depth. There's also a hormone called anti-Mullerian hormone secreted by the testes that will prevent any female sex organs from developing. At about 14 weeks, we start to see the beginnings or the primitive versions of testes and ovaries developing. And then the development of the external organs is dependent on dihydrogen testosterone, or DHT, produced by the testes. If DHT is present, we will see male external anatomy develop, and if it is absent, we will see female external anatomy develop instead. So let's look at both internal and external development of the sex organs throughout the weeks. Early on, we see this kind of not quite male, not quite female look, where we have these generic gonads. We have two different ducts, Mullerian and Wolffian ducts, a probladder, the kidneys, ureters, and a general purpose cloaca. Nothing's really looks male or female yet. At about 6 weeks is when the SRY gene will kick on if it's present. So if the SRY gene is present, we see that those gonads become testes. We see that the Wolffian ducts stick around because the anti-Mullerian hormone has gotten rid of the Mullerian ducts. And we see the formation of the internal male anatomy. If the SRY gene is absent at around week 6, then we see female reproductive organs form internally. Those gonads become ovaries. We see the Mullerian ducts become the oviducts. A uterus develops, and then a vaginal opening. So we see very female internal organs develop here. When we look at the external components, at around 4 weeks, we have a generic slit called a cloaca. At around 6 weeks, we start to see some openings and these urogenital grooves. But again, not quite male or female yet. It's when we look at the SRY gene, if it's present or not, that we start to see the development of male external anatomy or female external anatomy. If the SRY gene is present and DHT is released, then we see that urogenital groove is going to come together. We're going to see that kind of seam come along and seal things up. We see the glands, and eventually we see at around week 14 that has become the penis. And if the SRY gene is absent, that glands will not become the head of the penis. It will instead become the glands of the clitoris. And that urogenital groove, that opening, will be maintained to form the vaginal opening, as well as to form the exterior called the vulva. However, what we just talked about is under normal circumstances. So for the most part, that's what happens. However, there are times where the sex organs don't develop quite how you would expect. And that includes females who are actually chromosomally XY, as well as males who are chromosomally XX. Remember, we were looking at a very particular gene called the SRY gene. If that gene were to somehow make its way onto an X chromosome, then someone who is XX would in fact become male, even though they have two X's, because the SRY gene made its way onto one of those two X chromosomes. If someone is XY, but the SRY gene is somehow missing or deactivated, then even though they're XY, they'll develop as a female, since the information or the beacon saying become male has been lost. There's also some ambiguous sex determination that can happen because of the absence of testosterone, anti-Mullerian hormone, or DHT. Things like androgen insensitivity syndrome, where all of these hormones are made, but the receptors on the cells don't work. So the body is sending out the signal to say, hey, become male, but the cells have no way to understand that message. And so the cells then go towards becoming female. This would be an individual who does have testes, so they do have male gonads, but they don't fully function as male gonads, they don't properly descend, and on the outside, this person would appear female. There's also male pseudohermaphrodism, where an individual appears female until puberty, when suddenly anti-Mullerian hormone is produced, but the testes never produce testosterone or DHT. With androgen insensitivity syndrome, I'm about to show you a photo of someone who has androgen insensitivity syndrome. So here we see this person that if you were to look at, you would probably assume, based on the anatomy, that this person is female. This person probably was raised as female, socially speaking, and may have had no idea that anything was potentially abnormal about their body until they reached puberty. They would never have gotten a period. They would probably have gone to a doctor with questions about that, and it might have taken several years for anyone to figure out what was going on. So this person we're seeing here with androgen insensitivity syndrome, they have XY chromosomes, they have testosterone, they produce anti-Mullerian hormone, they produce DHT, and they have testes, but those testes are kept internal, and the cells of the body have not listened to any of the messages being sent by testosterone and DHT and whatnot. So this person, by all accounts, appears and would be treated as female. You can imagine how shocking that would be if you were to find out that, chromosomally speaking, you were male. So with something like this, it's important to note that biology does have gray areas when it comes to male and femaleness. Not every single person biologically fits the box of male and biologically fits the box of female. There's gray areas where someone may be some form of in-between, whether that be because of some sort of condition like androgen insensitivity syndrome, a faulty gene on a Y chromosome, or something in between. It's important to note that what we view as male and female is not just biology, but also how we look at it socially. Now, we won't get into the social aspects of this, but we want to make note that when it comes to biology, it really isn't as simple as some people make it out to be. There are individuals out there who do fall somewhere in between, that are not quite female as we would describe it, and not quite male. So when you're discussing topics like that, it's important to note what we really know in biology when it comes to sex, maleness, femaleness, and that there are individuals who don't quite fit that mold.